is we went through some of the introductory concepts of computer networks, right? So we tried to understand the history of computer networks. We tried to understand the different types of flows of data, simplex, half duplex, full duplex communication, etc. We also understood the concept of protocols that would be required in order to send data from one device to another device in the network. So we'll proceed further and we'll try to understand a couple of other things. We have also understood in the last class about the different types of connections that are relevant for computer networks. So for example, point-to-point, multi-point or multi-drop connection. We have understood the requirement of performance metrics, performance measures relevant to networks, such as throughput, delay, quality of service in general, reliability, security, and so on. So today we will proceed further and we'll try to understand the topologies. First, we are going to try to understand what is topology, and then in the backdrop of topologies, we'll try to understand the concept of switching. So remember that whatever we covered today in terms of topologies or switching, so this is going to be preliminary, this is going to be introductory still, and these concepts will be required further down the semester when we start covering some of the further advanced concepts in computer networks. So let us try to understand the concept of topology. So what is a topology, first of all? So topology means like how you are going to lay the different devices that are going to be connected in the network physically, so that two or more devices they can start talking to one another. So how you are going to physically lay the devices, the physical, it's basically the physical topology, right? So physically how you are going to lay the different devices. Okay, so just give me a moment, let me just quickly check one thing over here. Yeah, okay, fine. So let me go back. So how we are going to physically lay the different devices, the network in general, so that two or more devices they start communicating with one another. So when we talk about this, so what is the basic configuration of a computer network, right? The basic configuration could start with two different devices being connected through a wire, some kind of cable, so some kind of cable running between one device to another device. So these two devices could be two different computers, for example. So in your room itself right now, if you have two computers, right, you can connect those two computers with the help of a specialized cable, which I will talk about later on. It is called the crossover cable. So with the help of crossover cable, you can connect two computers directly so that they can talk to each other. Now this particular thing could be extended further. You can form a small home office kind of thing, right, where not just two computers, you can connect a printer, for example, right? So that would be a very simple kind of home office kind of scenario, which again can be scaled up further. So you can keep on adding devices to this basic configuration. You can keep on adding devices to this configuration, and the more you keep on adding more devices, you have to deal with the complexity, for which you need to understand the different concepts that we are going to cover in the semester. So let us start from the very basics. So first, let us try to understand this physical topology, the physical laying out of these devices. Let us try to understand how it can be done. So this physical laying out, the interconnection of these different devices, for example, multiple computers or different other devices that connect in the network, this can be done in different ways. So some of the very commonly used topologies are the mesh topology, the star topology, the bus topology, the ring topology. There is also something called the tree topology. There is also something called the hybrid topology, and so on and so forth. So there are many different topologies. These are only the basic ones which are quite relevant in the formation of computer networks. So try to understand that we are talking about more than two or more devices which will have to be interconnected in a certain way. So the question is that how you are going to connect them, in which formation you are going to do it, how the geometry is going to look like. So let us say that you have like 4 or 5 devices. How, so from device 1, D1, D2, D3, D4, D5, let us say you have 5 devices, right? So how you are going to lay the cables between them, right? So how they are going to be connected, randomly, or is there a certain way? So what are those possibilities? That is what we are concerned about at this point. So let us start with something called the mesh topology, which is very popular topology. And I told you in one of the previous classes, not one of the first class, I told you that my area of research is something called IoT networks, right? Internet of Things. So there actually we use this mesh topology a lot. Okay, so let us try to understand that in the context of computer networks, what is this mesh topology? So this mesh topology looks something like this. So what you see in this figure in front of you. So as you can see over here that we have a pentagonal kind of structure where there are in each of the vertices of this structure you have a computer, or it could be any other network device as well, right? So now the question is that how do you run the cables between these different computers? So in mesh topology, the idea is that you need to run from every device. Let us consider this device, right? From this device, you have a dedicated point to point. So this point to this point link between the devices. So from this device to this device, you have a dedicated point to point link. From this device to this device, you have another dedicated point to point link. Like this, the process continues. So from each device, you have a dedicated point to point link to all other devices. So you see that for all the devices, the process continues like this. So now you see that if we are talking about n nodes in the network, then what is going to happen? Simple combinatorics. So n nodes in the network, from one device, you can reach n minus 1 nodes. So like this, from the second device, n minus 1 nodes, like this, the process continues. So how many nodes, how many links are possible? How many links are possible? Who can tell? Anyone? Simple combinatorics. So from one device, you can reach n minus 1 devices, right? So you have n minus 1 links like this. From another device, you have n minus 1 links. From the third device, like that. So for the entire network, how many links do you need? Huh?
NC2, sir.
So what is it?
N in 10 minus 1 by 2.
Okay. So here actually you made the assumption that the the links are basically duplex, right? They support duplex mode communication, and I already told you what is duplex in the last class. So n into n minus 1 duplex mode links will be required in this kind of topology. So now you see that if every device has some ports means these are like kind of, just assume like these are kind of like jacks, let us say. So it's not like that, but for now you assume like that. So there is something called ports, right? So if every device has the capabilities, some ports are there for input output operations. So input output means some data are going to come through the input ports, output port. I mean, so through the output, basically the data are going to go out from that particular device and so on. So for every device, you need how many ports? N minus 1 input output ports, right? N minus 1 input output ports. So you see that this sort of topology is a very popular topology, because the question is that even if you have a lot of cables running between these different computers. A lot of cabling is required, right? Obviously, because from between all different pairs of computers, you need cables to be running through, right? But the advantage is that it gives a lot of reliability. So let us say that one link breaks. You still have other links which can help one computer to send some traffic to some other computer, because there will be some other link that will be there. So reliability of communication is enhanced with the help of mesh topology, but the downside is that the amount of cabling that is required is more. Now, there are few other very popular topologies also. For example, there is something called the star topology. So the star topology geometrically looks like a star, right? So in a star topology, as you can see in this particular figure, you have a central hub kind of thing. It's a switch, right? It's a central switch, and every computer basically is going to be connected directly through point-to-point links between the switch and that computer, right? So a star topology is where you have some direct connections of these individual computers or these devices to the central hub or the concentrator or the switch. So obviously, in such a topology, if one computer, let us say this one, wants to send some data to this computer, it has to pass through this switch. So this one wants to send something to this computer. So in this topology, it has to pass through the switch. So every pair of computers which want to talk to each other will have to send their data through this switch or this concentrator. So it acts like a manager, right? It acts like a manager. So this particular device, it acts like a manager which controls all the functions of the network, right? The other topology, which is also, it's a kind of a basic topology. It's called the bus topology. It's a very popular topology as well, but it's quite primitive. And nowadays, actually, because of the presence of switching networks, etc., this sort of topology is not that much used, but it is quite popular because it is kind of like the foundational topology that used to be there in the initial days of computer networks. So it is still relevant. It's not like it's completely obsolete, but it is it is less in use at present. So in the bus topology, you see, look at this particular figure. You have one, you have one backbone cable. You have one backbone cable like this, which runs across between 2 points. Let us say you have a point A, you have another point B. So there is a thick coaxial cable, typically it's a coaxial cable, which forms like a backbone cable, which runs across. Okay. Now, all the different nodes in the network like A, B, C, D, and E, they basically have these cables dropping. They have direct cables which are dropping onto this backbone cable. Okay. So these cables are typically, all these cables are typically these coaxial cables. Okay. So I will talk about tomorrow. I am going to talk about some of these cables, right? Different types of cables that are used in computer networks. So one of these types of cables is called the coaxial cables, right? And I think many of you have seen the coaxial cables, right? So coaxial cable, for example, like the set-top boxes, for example, right? The cable operators, so in the set-top boxes of the of your television set, you must have seen that there are coaxial cables that run into them, right? These are like, they have some kind of pin inside, which is kind of a wire conductor basically. So it's a kind of circular kind of thing. You must have noticed that, right? So that's the coaxial cable. So I'm going to show you some different types of cables tomorrow, virtually, of course. Physically I would have loved to show you, but that's not possible. So let me see, what I can show you for regarding the cables tomorrow. So the main point is that you have one big thick coaxial cable, which is called the bus, and onto the bus there are these different computers which are going to drop into them, into the bus with the help of thin coaxial cables. With the help of thin coaxial cables. So this is a thick coaxial cable, and these are the thin coaxial cables. Now you see there is something called BNC. BNC is an acronym, and so BNC connectors are required, right? So these specialized types of connectors are required to connect, right? So these are like kind of circular, spherical, not spherical, like cylindrical kind of connectors that are required. I will show you some of these BNC connectors tomorrow if I can, right? So so you means like again virtually, so it will be like pictures or videos or something like that. I will try to arrange something for you. Okay. So so this is how basically the bus topology looks like. And now you see there is something called the terminators, right? So these are like the cable ends, right? So the terminators are basically, these are like special kind of connectors, not connectors but special devices where the signals can be absorbed. Okay, so these terminators are going to absorb the signal. Can anyone tell me like why the signals will have to be absorbed at both the ends? Anyone? Quickly, please be responsive. Please be very quick. I do not know, whether you are attentive in the class or not. That's the problem with the virtual classes. So please, because we have a lot to cover, and it is in your interest. I could have covered less for you, but I want to basically make you very knowledgeable at the end of this course. Only if you can give me time and opportunity. Otherwise, so basically, the knowledge is going to be shallow. So anyone who can tell me why you need terminators which can absorb the signals at both the ends of this bus cable? No one? Anyone? Quickly. Otherwise, I have to call names. Yes.
It can reflect back and cause noise.
So that is what is desirable, or that is not desirable? Which one? You tell your name first.
I'm Shunanda.
Sunanda. So Sunanda. So reflections are desirable or not?
Not desirable.
Not desirable. So you are very right that so see, if you do not have this kind of device which is going to absorb the signal, then there will be reflections from both the ends, right? So reflections will cause unnecessary noise, right, in the data transfer. So that is the reason actually you need this kind of absorbing materials to be there in the form of terminators. Is this clear to everyone? Okay. Now, the next type of topology is called the ring topology. Now, ring topology, again, geometrically it looks like a ring, right? So geometrically it looks like a ring. So this sort of ring topology is typically used in local area networks, and the mechanism that is used is basically something called token passing, right? So token ring network. So it has its origin in IBM. Coming up with those days, earlier days, IBM coming up with this token ring network, and so token passing mechanism is used to regulate the traffic flow. Okay, so this is kind of a token ring network, right? So this token, basically the token that is sent, basically it's a frame, right? So this token basically is a frame. Okay, so what is a frame? This term you will not know, but it is kind of like, for now just assume that it's kind of a message, right? For now just assume that it's a message. So this frame basically, it has three fields. Primarily it has three fields, right? So it has three fields, let us say. So two of these fields basically will tell you the beginning of the frame and the end of the frame. Okay, so these are like the delimiters. Okay, so beginning of the frame and the end of the frame, you can understand from these two fields of the frame. Now the middle one is very interesting. This is where basically this additional information that is required to be passed in terms of controlling the message passing, etc. So that basically goes into this middle frame, right? Sorry, middle field in the frame. So this token, I hope that everybody understands what is this token. Now this token basically helps in governing the transmission process. So let us say, so let us say that this computer wants to send something, send some data to this particular computer, right? So this token is going to be passed, right? So the token is going to be passed. Let us say that first it is going to come. So you see that these arrows are shown over here, which shows that it is unidirectional, right? It is unidirectional. That the passing of the data, the token, etc. So all of these are unidirectional. Yeah. So basically, so let us say that a token is passed from here to here. So then, so this particular computer, it will get access to that particular token, and then it is going to check, whether the data is marked for it or not. If not, it is going to pass it forward, right? So and then it comes to this particular computer. It seizes the token, and then it marks it for being used, and for being it in use, and then it inserts the information, right? So like this, basically this process continues. Okay. Now so whichever computer in this process, whichever computer wants to send some information, it will first have to grab the token. It will first have to grab the token. The token is completely, it is in circular fashion, it is flowing. So the computer has to grab the token. It will have to grab the token. It will have to designate the token to be in use, and then it will, along with the token, it will insert the information that it wants to send. Okay. Now this busy token, now this token becomes busy. Now this busy token plus the message which is appended by it, it is going to be passed around in the circle. Then it is going to be copied when it is received in the intended destination, and then eventually it is going to be returned to the sender. So whichever computer, let us say that this one wants to send some data to this one, so this computer is going to grab that particular token, extract basically the information that it was supposed to receive, and then it is going to pass back that particular token onto the network. Okay. So this process basically continues like this. So that is the token topology. Sorry, not the token, but the ring topology. And then there are few other little advanced types of topologies, which is called the tree topology. So tree topology, basically it is kind of like a hybrid topology, which has characteristics of both the bus and start topologies. So you see over here, it looks like a tree. So you have kind of a the trunk of the tree kind of thing. So this is the bus, right? And coming away from these is not a single computer, but a star configuration of computers, right? So like this, actually this is the tree topology. So it's a combination of the bus and the star topologies. Okay. And these act like the hub that I had told you at the time of this star topology. Okay. So tree topology basically allows for the expansion of an existing network and enables the schools to configure a network to meet their needs. Now comes the hybrid topology. Hybrid topology, it's a kind of generic kind of topology where you can have different types of topologies being combined. It's a hybrid of multiple different types of topologies, not just the bus and the star, but multiple different types of topologies can be combined, right? So for example, over here you see that multiple, so each of these is a bus topology. So you have one bus topology, you have another bus topology, you have another bus topology, right? So and then you have this hub, and these individual buses, together forming kind of a star, right? So this is one type of hybrid. Like this, actually you can have different other types of hybrid topologies also to be formed. Okay. So is this clear so far? Any question? Now let me ask you some question over here. I told you about the ring topology, right? Now can you tell me what sort of network device will be required over here in each of these different computers? Can you tell like what sort of network device will be required in each of them? Anyone quickly? Yes. Quickly.
Just a receiver and a transmitter.
Not a transmitter. It is called a repeater. A repeater is required. Okay. Why a
Yes.
repeater is required? And what is a repeater? By the way, what is a repeater? So a repeater, basically, as this name suggests, it repeats the signals. So what kind of repetition we are talking about? So repeater, I will talk about these different type of network devices later on. But these repeaters, basically what they do is, so they basically rejuvenate these signals that come to them, right? In what way they rejuvenate? By increasing their signal strength, right? So what happens is that when a particular piece of signal, pulse basically, whenever a piece of signal comes to a or travels to a certain distance, what happens? So a signal basically travels through a wire for certain distance, right? So what happens? It loses certain energy while it does so, right? That is simple physics, right? So it loses certain energy. So now the energy is going to be lost if the signal travels for long distance. So after some time, the energy in the signal is going to be close to zero, or it is going to be so low that that signal will carry no further information in it. So that is the reason actually these repeaters are used, which are going to kind of refuel these signals with more energy. Okay. And so they are going to repeat these repeaters basically. If you are thinking in terms of the bits, basically these bits are going to be repeated, right? These bits are going to be repeated, right? So they are going to be repeated. So that is the way basically you make sure that the signal is not lost in the process of natural transmission. Okay. So these repeaters are used, because otherwise what will happen is if the signal travels for longer distance and continuously, if it signals if it travels, then so it's going to lose all its energy, and essentially that will result in the information being lost. Okay. So these repeaters are required. Okay. Now let me if there is no other question, any question quickly? Everybody is with me? So now let me do one thing. Let me try to, actually I need a blackboard now, right? So I don't have a blackboard. So let me try to experiment with something over here. I hope that this screen is also visible to you.
Yes, sir, it's visible. It is loading.
Okay. So let me do one thing. So let me try to draw something for you. Okay. So we need to really understand, really need to understand how these multiple computers are going to be connected. We need to really understand that, right? So one possibility we have already seen, right? One possibility we have already seen, that we can simply, let me see, how do I, so I am also trying it out first time, okay? So bear with me. So let us say that, so we want to form a network, right? So we can have this kind of, a backbone kind of cable. And then, as I said, we can drop, what do I do here? Drag? How does it work? Okay, something has come. Okay, so like that we can have these multiple ones like this. Okay. And once again, we this one or what? No. This one should be okay. Okay, let me grab one of these. Yeah. So like this, actually, we can have these, these rectangular boxes represent the computers, right? So we can have these different computers like C1, C2, C3, which are like hosts, which will be dropped onto this backbone kind of thing. So this is kind of a very simple kind of network that you can form. And if you are doing at home, then so it will be like a home or in a department kind of thing. Then you form a local area network, right? Now, so this one is actually, it is okay, it will work only if you have a few computers. Okay, only if you have a few computers. Now the main problem is that most of the LANs today, okay, uh, so they have several computers which will have to be interconnected. Okay, so for that you need the help of something called the switch. Okay, the switch basically helps in this. Now, so a switched network looks like this. So excuse me about this drawing over here, because what I'm trying to do is I don't even have a tab. I'm just doing it from my laptop, right? So drawing is becoming a little difficult. So in a switched network, you have these multiple these small rectangles basically represent, let us say, the different hosts or the different computers, right? Now each of them, they are going to be connected like this. Each of them, they are going to be connected like this, okay, to this device which is called the switch, okay, which is called the switch. Okay, so these are like smart devices which will be able to recognize, basically the switches will be able to recognize the destination address of the packet, and then accordingly they are going to guide the packet to the destination instead of sending to all the hosts. Because over here what was happening is, if this guy has to send something to this one, then this guy also gets a copy of it, right? So everybody gets a copy of that copy of that packet. Packet means like the information that has to be sent. So here in this kind of topology, for a few networks it is fine, but otherwise everybody basically gets a copy of everybody gets a copy of the packet, right? So in this kind of topology. Now in complex networks where you have large number of different devices, right? So these switches basically can help, because these switches can intelligently send the packet to the intended destination node. So a source node sends the packet, let us say that this is the source node and it has to send something to this node. So essentially the switch, what it is going to do is it is going to intelligently send the data. It knows where to send, which is the destination node, where it is located. Now the question is that where it is located, how do you know? How does the switch knows that where a particular device is located? So for that you need to take help of, basically so when you are talking about a local area network in that kind of scale, so this is fine. But if you are talking about like a larger kind of network, right, where you have to send some packet to some other destination node, right? So the switch will not know where to send the packet to. So how does it know where to send? So it takes help of the higher layer, which is called the network layer. So with the help of the concept of routing, basically, the routers, basically there are devices called routers, which are layer 3 devices. These layer 3 devices, you do not know what is a layer 3 device yet, so I will tell you about these things later on. So far we were talking about switches, right? Switch is basically a layer 2 device, and there is something called router, which is the layer 3 device. So layer 2 device, layer 3 device. So layer 2 device, if it doesn't know where to get the intended destination node, then the layer 3 device, which is the router, will help in informing the switch about where to send the packet to. Okay, so we will deal with all these complexities later on, but for now just try to understand the importance of these switches. So this is basically something called the local area network, right? So local area network, it's just a small kind of smaller kind of network, right? And it's just the dimension, that the scale basically is small, but this concept basically can be extended to interconnections over longer areas, right, longer distances, with the help of the WANs, which we talked about last class, right? So let us talk about this this wide area network, which is the WAN. Let us talk about WAN now. So with the help of this WAN, so let us talk about these WANs, right? Wide area network. So with the help of WAN, it is possible to send the data from one LAN to another LAN. So a LAN is typically restricted to, let us say, just a small office or a building or maximum a campus or something of that dimension, right? Now the WAN basically has a wider geographical span, right? So it can span across a town, a state, or even a country, right? So wide area network basically can span for longer distances like this. So typically you need to have service providers, the communication service providers running the WAN, whereas like an institute like IIT Kharagpur runs the WAN, right? It is kind of private to the IIT Kharagpur LAN becomes private to IIT Kharagpur, whereas the WAN basically is run by some service provider like the public service providers, communication service providers like Vodafone or BSNL or whatever. Okay, so now this WAN, let us try to understand that what sort of WAN connectivity we can have. So for this, you need two connecting devices, WAN devices. This is one WAN device, connecting device, and let us say that this is another WAN device, right? And you have a connecting medium like this, some backbone, connection. So this becomes, so this is like one end of the network, and this is another end of the network, and this one basically connects to, let us say, some local area network, and this one, let us say, connects to another local area network. So what do you have over here? You have point to point link in the WAN. You have a point to point WAN connectivity. So this is a point to point WAN connectivity. Okay. Now here also the same problem. If you are talking about scalability, so this becomes an issue, right? So for that, you need to take help of not point to point, but switching WANs. Okay, a switched WAN, let us say, and let us say switched WAN. So let us say that a switched WAN is going to look like this. So you are going to have one switch. You are going to have, let us say, another switch. These are all switches. Okay, another switch, and then you have another switch. So these switches, let us assume that these are connected like this. Oops. These are connected. Right? Let us say that these are connected like this. Okay. Now every switch gets to another network. This switch connects to multiple networks. This one connects to another network. This one could be connecting. Why it is happening like this every time? This one will be connecting like this. This one could be connecting like this, and so on and so forth. Okay. So this becomes a switch based LAN. Okay, a switching LAN. Okay. So for every, sorry, not switch LAN, switch WAN. Okay, so we are talking about WAN now. So a switched WAN basically is a network with more than two ends. So here what we had seen over here earlier what we had seen is a point-to-point WAN connectivity between two different networks. Okay, two switches are there between two different. So here what we are seeing is basically a switched WAN with more than two ends. So so now the question is that why do you need this kind of switched WAN? Exactly the same reason as in the case of this switched LAN basically. So basically with the help of this switched LAN, yeah, is the whiteboard visible to all? Nidhi has written. So is this whiteboard visible?
Yes, sir.
Okay, good. So basically, so what is the reason why you need a switched WAN then? Basically to make the intelligent decisions, right? Exactly to which switch it has to be sent, right? So instead of sending the data across and flooding all the switches with the same information, so a switch which receives the data, it knows exactly to which other switch it is going to send and how it is going to send. So that will be known to it, right? So this is basically the switched WAN. Okay. Now, if we are talking about the internetwork, right? So we have talked about LAN, switched LAN, WAN, point-to-point WAN, and point-to-point, and switched WAN. We are talked about 4 of these different types of topologies. Now let us talk about the internet work. So in an internet work, what is going to happen? Let us say that again, let us assume that we have, so let us say that, so this is one campus of IIT Kharagpur, right? So IIT Kharagpur also has multiple campuses, which you might be knowing by now. So let us say that IIT Kharagpur, let us say main campus, right? So our campus over here. And let us say that another one is IIT Kharagpur Bhubaneswar campus. Let us assume. So we have two different campuses, right? So you see that one is in Kharagpur, the other one is Bhubaneswar. You understand? So now the point is that this one runs, this main campus has this LAN over here, and this office, Bhubaneswar office, has another LAN. I'll try to find a better way of how we can do these drawings in future, right? So tomorrow it is not possible. Next week onwards, let me try to figure out a better way, because drawing like this becomes very difficult. Actually, these were supposed to be board work for me. I would have drawn on the board, but this is not being possible now. So let us say that you have two different LANs, right? And so let us say that you have a switched LAN. So this is one switch, and you have these multiple ones that like this, these multiple computers connected through the switch. Let us assume, right, over here. Similar thing over here as well. You have one switch, and then you have these multiple ones connected like this. Ready? Multiple ones connected like this, right? And let us assume that somebody, some office, let us say that the computer science and engineering department wants to send some data to some computer in the Bhubaneswar office. Okay, then what it has to do? So the first the data is going to come to the switch, then it is going to, so it is not within, so the switch cannot identify the destination, right? So it is then going to take help of a device which is called the router. So it is going to take help of the router. The router knows that where is the destination node. So it is in another part of the in another local area network, right? So the router basically will send to the corresponding router over here. Then once it arrives over here, So it is going to be sent, and over here the switch basically knows that which destination computer it has to be sent to, so it will be sent over here. So you see that once it passes the boundary of the LAN, the router basically helps in identifying how to send the packet to, where to send the packet to. So what do you have over here? You have a point to point, you have a point to point link between these two routers. You have a dedicated point to point link. Why do you need a dedicated point to point link? So how can you get it? You can lease basically from the service provider. So whoever is the the WAN service provider, basically you can have a point to point link being leased by the institution. So let us say IIT Kharagpur, to have this kind of connectivity. Point to point link can be leased, so that the the employees from one office can have communication, efficient communication with the employees of another office. Okay. So what is the time now? Time is up. You see, I could progress only this much. Any questions so far? Any question? So you see, what we can do now is that this is something that I have shown you, how we can build kind of a small internetwork comprising of two LANs, each having an individual switch connected through point to point link between two dedicated routers. Point to point dedicated link between two routers. So we have built a small internetwork. Now this thing can be extended further. This thing can be extended further. So then you can basically have a switched LAN, multiple switched WANs taking part in the process, so that the computer from an individual computer from a LAN will be able to talk to another computer which is there in another LAN of maybe another organization. It doesn't need to be necessarily of the same organization. It can be part of another organization. Okay. Any question? So next, what I'm going to teach you, now it is not possible, time is over, but what I'm going to teach you is how this switching is going to be done. And next, after a few classes, I'm going to talk about how this router is going to work, how this switch is going to work, what is the switching technique, and then how the router is going to come into picture. That we are going to cover when we discuss about something called the network layer. So for now, let us try to understand that what are the different switching techniques. So when I talk about switching techniques, today not possible again, maybe tomorrow. So when I talk about switching techniques, these switching techniques, different switching techniques are there. Okay, there are different switching techniques are there. These different switching techniques basically involve different layers in the communication stack. So we have not talked about communication stack yet, mind you. We'll do that later on. So my idea is that I'm trying to empower you in such a way that from a very small dedicated point to point link to building a complex internetwork, how we can do it step by step, right? So today we have learned how to build these different topologies, right? And then how to build small networks, starting from a LAN to a WAN to an internetwork. We have seen a brief idea, we have got a brief idea of it, and we are going to extend it further. Okay, so let us do that. Tomorrow we'll continue with this. Any question once again? Everybody is with me? Okay, very good. Okay, so thank you. Thanks all of you. Time is already over, and see you tomorrow. But see you today as well for the lab, right? So